Okay, so if she bought 2 pounds of almonds, how many pounds of figs did she buy? So we said, since we've already gone over this one, if there's 2 pounds of almonds and they were $6 a pound, how did we figure out how much we spent on almonds?
Multiplication.
We multiplied them, okay? So that was $12 for almonds. Okay, but again, that's not what it asked us. It wanted to know how many pounds of figs. So if we spent $75 total and we spent $12 on almonds, how are we going to figure out how much we spent on figs?
Subtraction.
We're going to subtract. So we're going to do 75 minus 12 almonds, and that's going to give us $63 on figs. But once again, it didn't want to know how much money we spent on figs. It wants us to know how many pounds that is. So then what are we going to do in our final step to see how many pounds that is?
Divide 63 by 9.
Divide 63 by 9, and that's going to give us 7 pounds of figs. Okay, so if we buy 2 pounds of almonds, then we'll have to buy 7 pounds of figs in order to spend that $75. Okay, let's look at number 2. It says, if we bought 1 pound of figs, how many pounds of almonds did she buy? So same exact type of question, and now, but we're just reversing figs and almonds. So what are we going to do first? What's our first step? If we bought 1 pound of figs, what do we do first? How are we going to figure out how much we spent on figs?
Would we multiply?
We would multiply. So if figs are $9 per pound and we bought 1 pound, what are we going to do? $9 times 1. So how much did we spend on figs? $9 on 1 pound of figs. Okay, but it didn't want to know how much money we spent on figs. It wanted us to know how many pounds of almonds we got. So what are we going to have to do with that $9?
Subtract.
Subtract it from what?
75.
75. So if we spent $75 total and 9 of that was from figs, then 66 of it was from almonds. Okay, but once again, it did not ask us how much money we spent on almonds. It asked us how many pounds of almonds we bought. So what are we going to now do with that $66?
Divide 66 by 6.
Divide it by 6 because it's $6 per pound of almonds. Okay, and 66 divided by 6 is what?
11.
11 pounds of almonds. Good. All right, so nothing new so far. There's nothing new about questions 1 or 2. Now, questions 3, that's a little bit new, but we've been talking about that in the last 4 lessons. So it wants us to write an equation that describes the relationship between the pounds of figs, I'm going to highlight it, the pounds of figs and the pounds of almonds that Claire bought and the dollar amount that she paid. Be sure to specify what the variables represent. Okay, so what variables can we use? Because at the very end it says be sure to specify what the variables represent. What variables could we use to represent pounds of figs and pounds of almonds?
You could do F for figs and A for almonds.
Good. So for F, that can be pounds of figs, and A is pounds of almonds. Good. Okay, so now we've got to set up this relationship. Now, what I want you to think about is back to lesson 1 when we talked about the pizzas and we were creating the equations for our pizza party. We had that cheese pizza and we had that pepperoni pizza, and then we had the price of the cheese, and then we had the price of the pepperoni. And the price was always dependent on how many we bought, which is the same thing for the almonds. The price of the almonds is going to depend on how many pounds of the almonds that we get, right? Do y'all agree? Okay, so how can I set this up to represent that relationships of the prices of the almonds and the figs and the amount of pounds that we're going to get? How could I show that mathematically? Okay, for example, we know that the dollar amounts that we're working with up here are 6 and 9. Okay, so if it's $6 for almonds, so write down 6. We know it's $6 for almonds and we buy some amount of pounds. What are we going to do with how many pounds that we buy?
Times it by 6.
Times it by 6. Okay, but do we know how many pounds of almonds that we bought?
No.
No.
What are we going to use instead?
F.
For almonds?
A.
A, because the $6, remember, that's the price of the almonds. So that's going to go 6A. Okay, now you can represent the multiplication multiple ways. You can put the little times dot, you can put it in parentheses, you can do any of those things, but I like to just keep it 6A. Okay, now we have the price. I'm going to kind of scoot over a little bit. Now we have the price of the figs. Okay, that's the price for 1 pound of figs. Do we know how many pounds of figs we're going to get?
No.
No. So what can we use in its place?
F.
F. Okay, so I want y'all to, if y'all can see my face, look at me. So if you have the price of the almonds here, that's the 6A. Okay, you're going to get that total. Then you're going to get the total of the 9 times F. How am I going to find out how much we spent all together? What mathematical operation would we have to do with the 6A and the 9F?
Addition.
We would have to add them together. Good. So I'm going to have to take that total amount of almonds. I'm going to have to take that total amount of figs, and we're going to have to add them together. All right. And then all of that has to equal our budget. What was our budget?
75.
75. That was our constraint that we had to meet. So good job, guys. Y'all came up with an equation for the situation. Good job. Okay, so none of that is technically new information, okay? If we're thinking back, if you look back to the title of this lesson, it's equations and their graphs, okay? So as we move forward in the next few questions, we're going to see how this equation and other equations that we come up with are now connected back to a graph, a graphical representation. So look at the next page. We're on page 4. And it says, here is a graph that represents the quantities in this situation. So we're still talking about almonds. If you look at your x-axis, we're still talking about the almonds. And if you look at the y, we're still looking at our y-axis of figs. Okay, and it represents that situation we just talked about, that 6A plus 9F equals 75. So just to be clear, this equation that I'm highlighting in blue that we just came up with is represented by this line right here. Okay, now A and B, you're going to do it on your own. So listen carefully when I explain the directions, please. It says on A, choose any point that is on the line. I want you to state its coordinates and explain what it tells us in the situation. So in order to explain what it tells us in the situation, once again, you have to read your graph. You got to know what your X and Y axis are talking about. Okay? So choose any point, once again, that's on the line, tell me its coordinates, and then explain what it means in the situation. Same for B. The only difference is you're going to choose any point that is not on the line. All right, and choose a point that's already given to you. You have A, B, C, D, and E on your graph. Use one of those points. Okay, and then state its coordinates, and then explain what it tells us. All right, remember coordinates are just those X and Y coordinates. All right, so I'm going to give y'all a few minutes, probably like 3 minutes should be plenty of time, and then we will discuss it. Ready, go. Okay, so it says choose any point on the line, state its coordinates. Okay, so someone give me one of the coordinates for part A that's on the line.
11-1.
Okay, 11-1. So you chose point B, which was 11-1. Okay, good. Now, if you chose something else, that's fine. As long as it was A or C, that's correct. That is good. All right, but someone tell me what 11-1 means in this situation.
There's 11 almonds and 1 fig pound of pounds. I'm not sure if that's right or not, but
yeah, 11 pounds of almonds and 1 pound of figs. Good. Okay. Moving on to number 2. It says choose any point that is not on the line, state its coordinates.
14-0.
Okay, so you chose point E. 14-0. And someone tell me what this point means in this situation.
She got 14 pounds of almonds and no pounds of figs.
Okay, 14 pounds of almonds and 0 pounds of figs. Okay, good. That is all correct. But let's talk about what was the significance of them asking us about values that were on the line versus values that were not on the line. Why do you think that they had us do that?
The things on the line would equal up to 75, and the things off the line will not.
Okay, that's a really good, that is a very good assumption, Braden. So Braden said that the values that were on the line, so I'm going to use, so points A, C, and B would all add up and give us that $75. Is there a way that we can prove that? What is that called? How can we prove that? That these coordinates right here, that the coordinates for B, substitution. I think that's what I heard. Okay, so let's see. So we take our equation. And y'all can just find some place on your paper. I know y'all don't have unlimited space like I do. Okay, and we're going to substitute in our values for almonds and figs. So I'll bring down my 6 because that price is staying the same. But instead of A, what am I going to put? What am I going to substitute in for A? If
11.
Yeah, if we're looking at point B, I'm sorry. 11. Okay, and then bring down my $9 for figs, but instead of F, I'm going to put
1.
1. All right, and then all of that should equal 75 according to Braden's assumption. Okay, so we're going to simplify. We have 6 times 11 and we have 9 times 1. What's 6 times 11?
66.
66. And then I'm going to add, what's 9 times 1?
9.
Good. All right, and 66 plus 9 is 75. All right, does 75 equal 75?
Yes.
Yes. Okay, so Braden said that the values on the line would add up to equal our constraint, 75. Is that true?
Yes.
Yes, it is true. Okay, so then we could say that every value that is on the line is a value that makes our equation true. Do y'all agree with that? Yeah, if it makes our equation true, what's that called? If it makes our equation true, what's it called? Starts with an S.
A solution.
A solution. Okay, so any value that in any coordinate that is on the line of the equation that we graph would be considered a solution. Okay, so then what do you think the significance of values are that are not on the line?
Not a solution.
They're not a solution. Good. Okay, so if we look back up at our graph, values D and E would not be considered solutions. All right, give me a thumbs up if that makes sense to y'all. Thumbs up before we move on. Good. Harmony, I need to see you or Rebecca and Caitlin. Is that good? Thumbs up.
Jesse just got here.
Jesse. Okay. Now, keep that in your mind. So what we just discovered is that if a coordinate is on the line, it is a solution. If it is not on the line, it is not a solution to the equation that we're working with. Okay, now remember the line that is on the graph, it comes from the equation. Okay, so let's look at 5.3. Okay, now this first one, we're going to do all of it together so that for number 2, y'all can do it on your own. So make sure y'all are really paying attention to all of the parts. I really like this question because it connects all the lessons into one question, okay? Which is really good because we know that every single thing we're talking about is slowly building on each other. So, number 1, it says a student has a savings account with $475 in it. Okay, this amount of money is already in her savings account. Okay, it says then that she deposits. The word deposits means that she's putting money into her savings account. So she is adding money to her savings account. All right, and she's adding $125 into her account every week. All right, and finally, her goal is to save $7,000 for college. All right, so the first 2 questions, just like the almonds and figs, just wants us to think about it and just like kind of play around with how the numbers are going to work together. So it says, how much will be in the account? So that's what it wants to know, and it tells us that after 3 weeks. Okay, so in order to do this, we have to think how much money is already in her account. How much money does she start with?
475.
475. So that money is already in there. Jesse, I think we're on page 167. Okay, so she already has $475 in her account. Okay, now she's depositing $125 into her account every week. Okay, so when we're depositing money, is she adding that to it or is she taking it away from it?
Adding it.
Adding it. So we can show that. All right, and how much is she adding to her account every week?
125.
All right, she's doing 125, but think about it like this. Okay, she adds 125 after 1 week. So how are we going to find out how much she saves after 3?
125 times 3.
Good. All right, so we have addition and multiplication. We need to do follow order of operations. So we do multiplication first. So what's 125 times 3? 375 plus 475 will give us $850. If y'all would like to go get a calculator from the back of my room, y'all can do that, or y'all can pull up the ones on your Chromebooks, or you can use your own calculator, not your phones. Okay, so after 3 weeks, how much money does she have in her savings account?
850.
850. Okay, next question. It's going to be pulled from all of this up here. Don't think about A anymore. Okay, we're moving on from A, and this is a new situation. Okay, it says, how long will it take before she has $1,350 in her account? Okay, so now we're trying to figure out how many weeks have passed. Okay, so how am I going to do that? What am I going to do mathematically?
You're going to divide.
We will divide, okay, but we have to do something else first. This is actually a 2-step problem. So there's something else we have to think about before we can divide it. Because it just wants to know how many weeks, okay? So we know she's saving $125 per week, but what do we also have to think about?
How many weeks it takes for her to save it.
Yeah, we have to think about that, but we also have to consider that $475 that she already had. Okay, so before you would divide it, what would you have to do with that amount you already started with?
Add it to the equation.
Not necessarily adding it to the equation.
Would
Do what?
you multiply?
Subtract? Is that what you're saying? I can't hear you.
Multiply.
Okay, let's think of it like this, okay? Because I don't want us to just guess an operation. So, just like on the last one, we started out with $475 in our account, right? All right, and each week we're adding $125. Do we know how many weeks? Or is that what we're looking for?
It's what we're looking for.
That's what we're looking for. So what can we use in place of a value we don't know?
A variable.
a variable, what would work for the amount of weeks?
W.
Okay. So I'm going to do 125W, and that equals, what amount are we trying to figure out?
Weeks.
1,350.
Good. Okay, so we're wanting to know how many weeks. So we've got to find out our W. Okay, so how am I going to figure out how many weeks that is? How am I going to find W?
Substitution?
Nope, you don't have anything to substitute. We have to get the variable
By itself.
by itself. If we want to know what W is, we have to solve for W. Okay, so I start with my term that is farthest away. How am I going to get rid of that 475?
Minus 475.
I'm going to subtract 475. If I do that to one side,
Did it?
Actually,
To
it's
the other.
got to do it to the other side. Okay, 475s, they cancel out. What am I left with? 25W equals 875. Okay, so that was the part that y'all were forgetting to do a second ago. Before we can divide that 125 from the total, we had to subtract off that 475 that we already had in our savings account. Okay, so now we have 125 times W. So how do I get rid of that 125?
divide it.
I divide it. And if I do that to one side,
Have to do it to the other.
I have to do it to the other side. And so I'm left with W equals 7. Okay, so how many weeks did it take her to save $1,350?
7 weeks.
7 weeks. Okay, so we've pretty much kind of jumped a little bit ahead for part C, but that's okay because now you'll see that pattern. It says write an equation that represents the relationship between the dollar amount in her account and the number of weeks of saving. Okay, so the values that I highlighted in yellow, the dollar amount in her account and the number of weeks of saving, are values that can change depending on the situation. Okay, so what do we use in place of values that can change or vary?
Variables.
Variables, okay? So what would be a good variable to represent the dollar amount in her account?
D.
D. Okay, so I'm just going to put that down here. The dollar amount in her account. And what did we say would work for the number of weeks?
W.
W. All right, so let's write an equation. Okay, what do we start off with? What do we know? What do we know that she's about this equation? What do we know she started with in her account?
She started with $475.
Okay, so if that's how much she started with in her account, that's what we're going to start with in our equation. So we have 475. And what's she doing to that each week?
Adding 125.
Okay, she's adding 125. All right, and she's doing that per week. Do we know how many weeks?
No.
Can that amount change? The weeks?
Yes.
Yes. So what do we use in its place?
W.
W. All right. And then that's going to tell us, wait, that will set us all equal to what? That's going to tell us what? When we know how many weeks, it's going to tell us.
There's an announcement.
Oh,
Um,
It's going to tell us the dollar amount in her account, right?
Right.
Okay. All right, so we have our equation that represents this situation. Okay, so we start out with $175. We're adding $125 per week, and that's going to tell us how much money is in her account. All right, moving on. Number 4, it says graph the equation using graphing technology. I'm going to do that with you. And then it says mark the points on the graph that represent the amount after 3 weeks. And the week she has $1,350. We're on number 4.
Or D.
On D. Yep. Okay, so I want y'all to just watch my screen while I do this, okay? Because y'all don't have access to this just yet. Okay, so what I've gone ahead and done is I've typed in the equation for you over here up in the top left-hand corner. You know, everyone looking at their Chromebooks. Okay, so I went ahead and wrote this. About the only thing about this website is you have to use X and Y values to represent everything. Okay, so I used, instead of W for weeks, I used X. Okay, now they've gone ahead and graphed it for us. So this red line going across your screen is representing the equation. All right, so it wanted us to focus in on how much money she had after 3 weeks. Okay, so if you look at your graph down here in the bottom right-hand corner of your screen, our x-axis is labeled weeks. Okay, and then our y-axis is labeled dollars. So if I'm looking in here and I've got 3 weeks as my X, my Y tells us what?
How much money?
How much money? So how much money did she have after 3 weeks?
$850.
850. Doesn't that sound familiar? Isn't that what we just said on part A?
Yes, that is.
It is. Okay, so we're going to write down that coordinate. So that coordinate was 3,850. All right, now it also wanted us to write down the coordinate for when she has $1,350 in her account. Okay, so let's go back to our graph. All right, and we know our Y value tells us when we have 1,350. So what week was that?
7 weeks.
7. Okay, so we're going to write that coordinate down. So that was 1,350. Okay, so looking at that, we know that our X value always told us the week, and our Y value always told us the amount of money that was in the account. What did you also notice about the 2 points we looked at? What do you notice about them that we've talked about prior to this?
both on the line.
They're both on the line. Okay, so if they're both on the line of this equation, what does that tell us?
They are a solution.
Solutions.
They're solutions. So I can click on this line and I can look anywhere. So right here, I'm at 4. How much money did she save after 4 weeks?
$975.
Good. Okay. What about, that was 4. What about after 5 weeks?
1,100.
1,100.
Yes. Okay, so anywhere I scroll on this line, it's going to tell me all those coordinates that make my equation true. Okay, anywhere on it, I could find that. All right, so looking back at our next question, it said, how long will it take her to reach her goal? Well, what was her goal? What was the goal that she was trying to get to?
7,000.
$7,000. Okay, so we could easily type that into our equation and solve it out. But what this is wanting you to see is that if you have a graph, if you have the opportunity to graph it, you can see all of these solutions in the graph. So I'm going to go over here to my y-axis. I'm going to go all the way up to 7,000. All right, and they've already kind of graphed this orange line for us. So I want to see where that intersects at my equation line. And it's right there. So how many weeks does it take to save $7,000?
52.2 weeks.
52.2 weeks. Good. All right, now this next one I want you all to do on your own. Okay, I'm going to help you all get it started just to read through the question, the situation, and then I want you all to do parts A, B, and C on your own, and then we will do D and E together. Okay, so let's look at the situation. One second. All right, there we go. So it says we have a 450-gallon tank full of water. So this thing is currently full of water. And it is draining. Okay, draining at a rate of 20 gallons per minute. Okay, so we start with I want you to imagine, think of a big tank. Okay, that whole entire tank is full of water. Okay, and then something happens and it is now draining, and it's draining at a rate of 20 gallons per minute. Okay, I want you to see if you can answer questions A, B, and C. If along the way you want to check with me on the answer, just send it in the chat and I can check your answers as you're going to see if you're on the right track. I'm going to give you about 4 minutes to do A, B, and C. If you finish before my timer goes out, please send it in the chat and let me check it. Okay, and don't sit there. If you I would rather you do it all and get it wrong, and then we can talk about it. Okay, all right, here we go. All right, 4 minutes starts now. Okay, so let's look at it together. It says how many gallons will be in the tank after 7 minutes. So someone tell me how I'm going to figure this out. What's going to be my first step?
Multiplication.
Okay, what am I going to multiply, Jocelyn?
7 times 20.
Okay, I'm going to do 7 times 20. All right, and once I know that, what am I going to do with it?
Subtract it from 450.
Okay, so since I started with 450 gallons of water in the tank, I have to subtract that off of that amount to see how much will still be in the tank. Okay, so once I do that, 20 times 7 is 140. 450 minus 140 is 310 gallons. Okay. So for part B, it says, how long will it take for the tank to have 200 gallons in it? Now, I think only a couple people sent in this answer, but the ones who did got it correct. So how am I going to go about solving this one? What do I have to do first? Some of y'all got it right. Tell me how you did it. Jesse, how'd you do it?
Oh dang, I forgot one second.
Do what?
I forgot.
Okay. So if we're doing this, we have to account for the 450 gallons that are already in the tank. All right. So then we have to, so we want to know how long it took to get to 200 gallons. So we have to think about the rate that it took to get from 450 to 200. So we need to know how much that difference is. So we're going to have to subtract those two values, which is going to give us 250. So from 450 to get to 200, they lost 250 gallons of water. Okay, so if they lose 20 gallons per minute, how are we going to figure out how long that takes? What are we going to do with the 250?
Divided by 20.
We're going to divide it by the 20 gallons per minute, which is going to give us 12.5 minutes to lose 250 gallons. Good. Okay, so after 7 minutes, that's 310 gallons. And after 12 and a half minutes, that's 200 gallons that are left in the tank. Okay, now it wants us to write an equation that represents the relationship between the gallons of water that are in the tank and the minutes the tank has been draining. Okay, so those last two things that I highlighted are the values that are going to be changing throughout the equation. So if we are talking about values that are changing, what do we use in their place?
Variables.
Variables. Okay, good. So what's a variable that will work for the gallons of water in the tank?
G.
G.
G. Okay. And what about the minutes the tank has been draining?
M.
M.
M. M. Okay, so just like we did for the first two, what amount did we start with?
450 gallons.
450 gallons. Okay. All right. And what's happening to that 450 gallon tank?
It's decreasing.
It's decreasing at what rate?
20 gallons a minute.
Okay, 20 gallons per minute. Now, the minutes, that amount can vary depending on when you're looking at it. Okay, so what can I use in place of that minutes to show that it's changing?
M.
All right, and then depending on the minute, it's going to tell us how many gallons of water are left in the tank. So all of that should be set equal to what?
G.
G. All right, so there is our equation for this situation. Now, for part D, it wants us to graph it using graphing technology. Again, mark the points on the graph that represent 7 minutes and when the tank has 200 gallons in it. Okay, so let's go back to my graphing page. All right, So I've gone ahead and I have written the equation here. Like I said earlier, it only works if you use X and Y. Okay, so I'm using X to represent minutes and I'm using Y to represent gallons of water in the tank. Does that make sense?
Yes.
Thumbs up. Okay, good. So here's our line. You can see it represented here. It's very steep because it started all the way at 450 gallons before the time started. Okay, and then the steep slope of it represents just how quickly it's decreasing. Okay, so it wants to know, the question was, mark the points on the graph that represent the gallons after 7 minutes. Okay, well, minutes was our X value. So we want to know when X equals 7. Okay, so do you see how it's going to give me a purple line on my screen over here off to the, on your left side, it has a little purple squiggle by it, by X equals 7. Okay, so that means that on my graph, it's going to be a purple line. So I'm going to zoom in. And so that X, or that line started at 7. So I got to see where it crosses through my line, because where it crosses through my line is going to be a what? A solution, right? Okay, so when we're at 7 weeks, how much, not weeks, when we're at 7 minutes, how many gallons are in the tank?
310.
310, good. Isn't that what we said earlier?
Yes.
Yes.
Okay, so let's write down that coordinate. So we had at 7 minutes, there were 310 gallons. Okay. Now we want to know how much time has gone when there's 200 gallons, right? So let's go back to our graph. Get rid of that. And now gallons was represented by our Y variable, right? So I'm going to do Y equals 200. All right, now it gives me that horizontal line. And once again, I want to see where it crosses through and how many minutes had passed.
12 and a half.
12 and a half. Good. All right. So once again, we had 12 and a half and 200. Okay, which once again is what we said earlier. Okay, so what they're wanting you to see, like I said earlier, is that if you have an equation, sometimes it's just easier to graph it and then find those solutions on your graph if you have the right kind of graphing technology to do that. Okay, Desmos is really, really a good way to do that. Okay, last, for E, it says, how long will it take for the tank to be empty? If the tank is empty, how many gallons of water does it have in it?
0.
It has 0 gallons of water, and we want to know how long that is. So we're looking for minutes. So we could easily type that back into our equation and try to figure it out, but it's a lot easier if we just go to our graph. So if all the way up here at 450 represents when it's full, then when it's decreasing, we go all the way down to when it's, nope, that's 200, sorry. Keep going, to where it's 0. Then we gotta see where that's gonna be on our line. So how long did it take until the tank was at 0?
22 and a half minutes.
22 and a half minutes. Good. Okay, so what we saw over and over and over again is that equations and graphs are not completely two separate things. When you are looking at a graph of an equation, the line that you see is the equation, okay? And so any value that's on those lines is the X and Y coordinates that make that equation true. Okay, so if we go down to our lesson summary, we're on page 169. We're going to start highlighting this. It says, like an equation, a graph can give us information about the relationship between quantities and constraints on them. Okay, so just like I said, equations can tell you stuff that the graph can also tell you. Okay, here's a real world situation right here. Whoops. All right, we're going to be buying beans and rice, and we plan to spend $120. Beans cost $2, rice costs 50 cents. All right, and they want us to use this equation to represent it. Now, oh, sorry. X stands for pounds of beans. Y stands for pounds of rice. So what I want you to notice though, before we get into what we just talked about in this lesson, just to bring it back to writing those equations, if you're looking at this equation that they gave us, the dollar amounts, the $2, the 50 cents, and the 120, those values are not going to change. They're represented by their actual numbers, but the X and Y, which stands for the pounds of beans and the pounds of rice, all of the cost is going to depend on how many pounds of beans and rice you get. So those amounts can change. So that's why the pounds of beans and rice are represented by variables. Okay, so they use this equation, they use this graph to represent this equation. So we know that this line is that 2x plus 0.5y equals 120. So what do we already know is true about these values right here? What do we know is true about those?
Their solution.
They're solutions, good. And we know that because they're on the line. What do we know is true about these values right here?
They're not a solution.
They're not a solution because they are not on the line. Now, just because they're not solutions doesn't mean they don't still have meaning. We just know that they wouldn't make our equation true. Okay, let y'all get that copied down. And then last page, it says, well, let me get it in the frame. It says each point on the line is a pair of X and Y values that make the equation true. And we know that if it makes the equation true, then it is a solution. It is a pair of values that satisfy the constraints in the situation. So if we were to look at point 10, 200, that's on the line. Well, we already know it's a solution because it's on the line. That just means we're buying 10 pounds of beans and 200 pounds of rice. And if we plug it back into our equation or substitute it in, it's going to equal that $120 that we're working with. Okay, and in that same idea, what about points that are not on the line? They are not solutions because they don't satisfy the constraints, but they still have meaning in the situation, just like I said. So if they're not on the line, they are not solutions. Okay, So it gives you an example of what it means for it to still have meaning in the situation. So if we looked at point 2080, it's not on the line. So if I go back up to the graph, they're talking about this point right here. All right. The first thing I notice about this point is that it's below the line. Do y'all see that? Do y'all see that this point right here is below the line? Okay. So if we go back down, it says that that coordinate still means that we're buying 20 pounds of beans and 80 pounds of rice. But when we put it and substitute it into our equation, it's going to equal $80, which we know does not equal that $120 constraint. Okay. But because it was below the line, it represents a cost that is less than what we intend to spend. Okay, so that cost was less than 120, so it's below the line. Okay, so if that's true, if this value right here, represents a value or a cost that is less than 120, what do you think this one will represent?
A cost that's higher than 120.
A cost that's higher than 120. Any value that I could graph above this line is going to add up to be more than 120. Any value that I choose, or any coordinate that I choose below the line, is going to add up and be less than 120. Okay, and that's why the ones only on the line represent values that would equal 120. All right, so that is it for